Okay, guys, today we are going to be dividing radicals. So we've been multiplying, we've added and subtracted, and now we are using the quotient rule, so we are dividing. Okay, so what's happening here is whenever you have a fraction underneath a radical sign, okay, sometimes it's advantageous to break it up into the square root of the numerator over the square root of the denominator. Or if they are broken up and it's advantageous to bring them together, we can bring them together. But they behave exactly like fractions would underneath the radical. All right, so many times before I take square roots, I may look to reduce. Now, in this first example, we've got the square root of 36 over 25. Well, this one makes sense to break up because I don't like this fraction. I have no idea what this fraction would represent. It's a little bit over 1, but that doesn't really help me much. But I do know that 36 and 25 are perfect squares. So if I break this up into the square root of 36 over the square root of 25, I can then take the square root of 36, which gives me 6, and the square root of 25, which gives me 5, and I've got my nice rational value. Okay, now we're going to have a couple examples that will be like that. So this is nice and simple. Here, I've got 64/81. So I know that's less than 1, but I don't know exactly what decimal that's going to be. But now when I recognize that the 64 is a square root, I'm going to break this up into the square root of 64. And I know that 81 is a perfect square. I'm going to break that up into the square root of 81. Square root of 64 is going to give me an 8, and the square root of 81 is going to give me a 9. So look a little rough. When we break it down into pieces, we can get a nice, clear, simple answer of 8/9. 1/16. 1 is a perfect square of itself, and 16 is a perfect square. So we'll break those two up. Square root of 1 is 1, and the square root of 16 is 4. Okay, so we still simplify to a nice, easy answer. Okay, now 45 is not a perfect square, and neither is root 5. Excuse me. So what we can do is break them up. In this case, it just so happens that one of the factors is a perfect square, but I'm more concerned with trying to cancel the root 5. Anything over itself is 1. So I can cancel a root 5 with a root 5 to just be 1. And now I'm left with square root 9. The square root of 9 just so happens to be 3. Okay, so we did break this up and got a perfect square factor, but sometimes we wouldn't. If this was the square root of 35, okay, I would have broken it up into the square root 7 and square root 5, still to cancel the root 5s and leave me with root 7, okay? Now, last example, before we get into a different video of rationalizing denominators. Here, again, I'm looking at perfect squares. Just so happens I'm going to break this up into root 4 and root 20. Now, root 20 has a perfect square factor in it. I don't care. I'm looking to cancel the root 20s. Anything over itself is 1. So just like 20 over 20 is 1, root 20 over root 20 is also going to be 1. And there it's going to simplify to a nice, easy number of 2.